before, but I'll still explain to you what the concept is. The concept of TCP state bypass. TCP state bypass. What does it mean? And where do we use it? Say for example, you don't have one PIX in your company. You have a company, let's do this here. You have two firewalls, FW1, FW2, connected to the internet, right? Your traffic is going through two firewalls, two different ISPs. This is one ISP, this is one ISP, this is the cloud they connect up to. And you're trying to talk to this server right here. So your packet that is coming out, say from this firewall, will pass from here, go through this firewall. A connection table will be set up on which firewall? Firewall 1. Right? So your SYN packet goes out. Say your SYN ACK also comes back this way. So your connection table is completely set. Then you set another packet from here. It will go to the destination. But one of the replies when it comes back in, it comes back from which firewall? Firewall 2. Comes back in from a different firewall. Is it going to take this packet?
No.
This packet is going to be dropped. Now this is not usually what you do. In usual circumstances, you will not have something like this. But in case you have something happening like this, that connection is going through one firewall, coming back through a different firewall. For a certain type of connection. Maybe the ISP, that whatever server you're trying to reach, is reachable on this direction from here, and for him to come to you, he has a better path to come in. How, in this case, will you make sure that this communication is not distorted? In this case, what you do is something known as TCP state bypass. You tell the firewall specifically in an access list saying traffic going from R1 to whatever PC, 200, 1.1.1. For it, you set connection parameters to TCP state bypass. Means for this connection, do not check the connection entries. Let him come back in. You'll do it on both firewalls. So for this kind of traffic, you will not treat this traffic as a normal TCP traffic. You will treat this separately and let the connection come back in from here. So the traffic which comes in, he does not care if this has a SYN packet or not. If it has a SYN packet, it will let him in. If it matches the access list, it will let him in. It does not matter which port number, which. It's a dangerous thing to do, obviously. It's a dangerous thing to do. But if you don't have any option and you're using something like this, you'll use this TCP state bypass option. There's a I think
It will allow all
document.
the traffic.
The one which you specify in the access list. TCP state bypass. To configure it is easy. See, this is the thing. Right? Your traffic is going out from here, but it's coming back from the other side. How do you prevent this from happening? Create a class map, match access list, bypass. What is access list bypass? It will be an access list which measures the exact traffic going from your R1 to that PC, whichever you want to. Make sure that the connection does not break. And then policy map, whatever, call the class. Set connection, remember set connection? Advanced options. Here I only had one option of TCP map, but you also have another option called TCP state bypass. And apply the service policy. That's all you have to do. If you do that, it's done. There you go. TCP state bypass. Just enable TCP state bypass for this connection. Do not do it for all your traffic. Do it for the traffic that is important to you. See here, he creates that access list going from 10.1.1.0 to anywhere, right? 10.1.0 is somewhere here. So any traffic leaving this interface, even if it comes back from this side, does not matter because that will be allowed to come back. Different ISPs. They're connected through different ISPs.
Both the ASs.
What? This? Both ASs. Both ASs. Because it might come out from here and come back in from the other side. So you allow both sides. Both it. Both this guy also and this guy. Because you never know, some traffic may go from here, some traffic may go from here. It will come back from here, come back from here. So allow basically this traffic to come in from both directions. TCP state bypass. Okay? That is one. It's called asymmetric routing, not usually used. Usually you will not use something like this. Usually when you have two ISPs, one will be used for backup, one will be used as your primary ISP. This will always create problems. Here no, there's no BGP used. This is not BGP, this is a default route towards the ISP, default route towards the ISP. BGP is not used when you connect from your house to the internet. Do you use BGP?
No.
You just have a default route towards the ISP.
No, you have just one ISP.
If you have two ISPs even, you will have two default routes. One with a lower administrative distance, one with a normal administrative difference. So all will go through this. But if this goes down, the other side will come up. Or you could have that SLA monitoring that will monitor this one link completely. So if this link goes down, he'll move on to the second link. BGP you only use if you have a network inside and you want this network to be hosted on the internet. Plus you'll have two connections of the internet. Then you'll use BGP. If you have only one connection from the internet and you want to host something on the internet, you will just tell your ISP to have a static route towards your network. That will be okay. But if you have two ISPs, now you cannot tell both of them to have a static route, because that will be redundancy. Both of ISPs will have one network which will be the same. So in that case, you do what? You do run BGP with this ISP as well as this ISP. And then you share your routes, it will be shared everywhere. So if this side goes down, automatically this side will be used. Okay? Clear? That is your TCP state bypass. The other thing, the last thing that we are going to be doing today, yeah? Repeat it again. Sure. See, I'll do this on the diagram. You have a company. Now, usual circumstances, no one does that. But if, in case your company has two ISPs, so your traffic, some of the traffic is going this way, some of the traffic is going this way. You never know. Maybe incoming you're having this, outgoing you're having this. Right? You configure it in a way that outgoing traffic is this side, incoming is this way. So in this case, whatever traffic is going out from here, right? Your SYN packet goes out, a connection entry is created for the traffic to come back in. On which firewall? This. So if the traffic comes back into this firewall, it will let him in. The problem is that the traffic is not coming from here, it's coming from a different firewall. Which one? ASA 2. Traffic is coming back from ASA 2. Does it have a connection entry? No. Doesn't have a connection entry. So what you do is, on this firewall, right now I'm only talking about if this is outgoing and this is incoming. Problem is on this, right? Incoming traffic is blocked. On this firewall, you say, alright, listen. For this traffic which is originated from 10.1.1.0. For this traffic, TCP state bypass. State bypass means does not matter. See, if this is a SYN connection, it won't be allowed to come in. A SYN will not be allowed to come in. But a reply to a SYN, which can be anything else. Right? He checks it here. The packet says I was originated from inside. The firewall does not know because it does not have a connection table. But since you've told him state bypass, means, okay, it was originated by inside and I've been told that this connection will be originated by inside because TCP state bypass. So he lets him come back in. Okay, but if there's someone else from here trying to come in using a SYN packet, will not be allowed to come. Only that specific network and not a SYN packet, a reply to a SYN, either a SYN ACK or an ACK, or a normal traffic, any normal traffic, except for SYN. So no one will be able to create a connection from outside to this, but a reply will come in. Okay? Clear? Good? That is TCP, state bypass. The last thing that we are going to be doing is traceroute through a firewall. Let's see how this works. Okay? First, before we do that, first we need to see how a traceroute works. Does anyone here know how it works? How does a traceroute work? How do you get the route to the final destination? If right now if I traceroute A.A.A.8, what is it going to give me? All the hops from here until A.8. So the first hop is this, then the second hop is this, then the third hop is this, the fourth hop is something else. How does this router, my NIC card, know all the hops until the destination? How does it work?
Is the architecture.
Nothing to do with ARP. Nothing to do with ARP. Check this out. My PC is right here with the NIC card connected to my router, which is 172.16.2.200. This, right? Then, which is connected in turn to whatever, say 121.3.4.6, connected in turn to 160.2.5.6, finally connected to the final 8.8.8 TTL. How it works is it sends out a packet, traceroute sends out a packet, UDP packet 33434 to 33464. The range of the port numbers in the destination is this. Any one of these values will be used as the port number for UDP, for traceroute, right? But the problem with this packet, not the problem, is the character is TTL of this packet is only 1. Time to live is 1. The packet is ping is to destination what? The packet is destined to 8.8.8. So the router looks up 8.8, looks at the route that he's going to 8.8, then forwards it to this interface. Now when he's forwarding it, he needs to reduce the TTL. He needs to reduce the TTL by 1. Let's leave here. Let's see what happens here first. I don't want to confuse you here. So let's see when the packet reaches here, right? 8.8.8. Router looks up the 8.8, looks up 8.8 is going from which interface? This interface. He moves it to that interface and the TTL is reduced, becomes what? 0. So the packet dies. When the packet dies, the router's responsibility to tell the PC that the router dies. How does he tell the PC? By sending an ICMP unreachable. Tells him, hey, the ICMP is unreachable. The router counts the total number of, the PC counts the total number of unreachables. How many did he get? 1. In this unreachable, will there be the IP address of this router?
Yes.
Because the source will be used as the IP. So the first hop is 2.200. Then what it does is, see, the first died, then he sends again. But this time he doesn't use a TTL of 1, he uses a TTL of 2. The packet goes here, checks where to leave from, crosses this hop, TTL becomes 1. He reaches the other router. checks where to leave from, TTL becomes again 0, the packet dies. What does this router do? Send ICMP message back again. Will the source be included? Yes. So the next hop is 4.6. Receives it. Then he needs to send another one, right? What is the TTL this time? 3. And this port numbers also keep on changing. So one packet is 33434, the other is 33435. Depends. It's random numbers which he chooses among these. Right? Sends the packet, first hop crossed, TTL becomes 2. For the other half crossed, TTL becomes 1. He reaches this guy, TTL dies. He sends out another unreachable with his hop in it. So the third hop is 160.2.5.6. Then sends another TTL out. So this keeps on continuing. Now TTL will be 4. He keeps on increasing the TTL. The moment he increases the TTL, he'll always get what the next hop is until it reaches the final destination.
I have a question. The TTL is maximum to 254.
255.
255. If someone, we don't know how many routers or how many is in their cloud is
Yeah.
there. So how can, if it is reaches more than that,
255.
more than that,
There's no way a router will be 255 hops away. There'll be no
maybe
communication
the
if it
connection
is.
is coming from where we don't know.
The maximum hops on the internet is 30.
30.
Yeah. More than 30 it does not accept. The route is considered invalid.
Okay. It's pretty different.
Yeah. 30 is the maximum for trace route
On the internet.
on the internet.
Oh,
30. 30 is more than enough. If you have more than 30, the connection will be very slow, so they consider the route dead. 30 hops is a lot on the internet. There's 30 autonomous systems that you're crossing.
wow.
It's a lot. Because Airtel will have one address, Vodafone will have one address. So you're crossing one ISP at a time to reach from one place to another.
But then that won't just be just one server. It will be multiple servers combined bearing the same IP address.
Yeah. Whole
All
ISP
over
with
the
one.
world.
Yes. But this is the total hops that you're taking. One router, then you go another router, then you go another router, then you go another router, and so on.
So how do they combine everything and give it just one IP address? So how do they combine all the servers and give it one IP address?
It's done using, see, with BGP, you can have one autonomous system. One autonomous system will have one scheme of IP addresses. It will have one whole network. 192, say 192.1.30./24 will be theirs. So one router will be .1, .2, .3, .4, .5, but the first 3 subnets will be the same.
What was that particular Google
Yeah.
server, the 8.8.
8.8, yeah.
Yes, because one thing I know is there will be many servers throughout the world
For 8.8,
for these are 8.
it's done using NAT load balancing. I taught you that in SNRS. NAT load balancing. One address on the on the outside. Inside you have couple of servers, 4 or 5 servers responding to one IP address. So one packet comes to 8.8, goes to the first server. The second packet comes to 8.8, goes to the second server. The third comes to 8.8, goes to the third server. NAT load balancing. So you can have 4 servers on the inside, but from the outside just one. Everything comes into that one and multiplies into the others. Okay, so that is the job for today. Now the problem with through the firewall is, let's have a look through the firewall now. Why is it getting stopped? Last packet will go TTL4, it'll reach the final destination. He will not get a destination unreachable back. So he knows that communication is finished. So he counts that hop, names it as 8.8. Yeah, every time. TTL1, TTL2, TTL3, TTL4. If he doesn't get a reply, he knows that he reaches the destination. So he says trace route complete. Doesn't get an unreachable back, yes. That means it reached. If it doesn't get an unreachable, that means it reached the final destination. Okay? Clear? Now, through the firewall, the question is, I have the firewall here, right? My scenario right now is this is R1, this is R2, right? My packet, this guy is trying to trace route in. Why is it getting stopped? What is getting stopped?
Outside to inside.
Outside to inside. This is outside, right? And this is inside. How do I let this happen? How do I allow it to come in? Access list. Let's create that access list on the PICs.
But from inside to outside it should be allowed.
Inside to outside is allowed, but ICMP unreachable,
Outside to
right? ICMP unreachable is coming from outside to inside. In that case, I'll have to allow ICMP to come in. First, let's try outside to inside on the ASA. Access list, INF, permit what? Which protocol? UDP. He'll send out, I'll be sending back ICMPs. But what will I receive? UDPs. Permit UDP from source any, destination any. Whoever is trying to trace route wherever. Right? Equal to, I will not say equal to, I'll say range. 33434 to 464. Any UDP in this range should be allowed. Okay? Access group, INF in interface. Let's try now. R2 to R1. Do you see any error? It's working now, but how many hops is it showing you? But there should be how many hops? It's actually 2. 1 hop from here and then the final hop. 2 hops. But it's showing what? And which address is he using? 10.11.11.1. The firewall's address is 192.1.20.10. He's not showing that. Why? This is exactly why I wanted to teach you this. Because the firewall, by default, does not decrement a firewall by default does not decrement TTL. So this UDP packet that comes in, it goes in here, goes straight up to R1. The TTL is not decremented, so that TTL1 remains. So that the first hop it gets is R1. He gets the destination is reached, so he thinks it's fine, everything is okay.
firewall is actually transparent for this.
For trace route, firewall is transparent. Why? Because by default, no one should know where your firewall is. No one should know where your firewall is. So even if someone trace routes, they will not know where the firewall. It acts as a transparent device in the middle. It does not decrement any TTL of any packet which is going through it. Okay? It acts as a transparent router. A transparent router. Now, I don't want this. I want to see this. You know, I want to see this. Why? Because I don't want security. I just want to see this work. So how do I do that? Through same set connection advanced options. Conf T class map. This will be for trace. Match any. Policy map. Global underscore policy. Class trace. Set connection. Decrement TTL. By default it's off. I'm saying turn it on. Right? So let's try now. Done? Now you're getting 10, 11, 11, 10. Why 10, 11, 11, 10? Why not 192.1.20.10? Because I told you TTL is decremented when you cross the router and reach this interface. So this interface replies. Here the TTL is not decremented. When you cross the router, go to the other interface, then the TTL is taken off. That's why he sends you a reply from 10.11.11.10. If you want to have a look, oh my, that's good. This is also on. See, destination unreachable is thrown off. First a UDP goes, this is which port number? 33437, 33438, 33439. And then a reply comes, and if you want to check the TTLs also, should be able to check it. TTL is 1. And for this, TTL is 1 because the destination unreachable is coming through. Okay, you understand this, how it works? What? ICMP unreachable. When the TTL dies, the router is responsible for sending it back. It's just like in a post office. When you send a letter and one of the post office receives the letter, but the address says, say, Quahog or some place which is unknown to the post office. What does the post office do? He checks the source, sends the packet back. Right? That's exactly what this does. If the packet does not reach, it dies. Now the post office guy is responsible to tell the source that, hey, the packet died. So he sends an ICMP unreachable saying, hey, the packet has died.
The second one should be with the TTL value 2.
Which one?
Second one.
This is 1. What is the destination? TTL should be higher, yes. Where am I monitoring? Question is, where am I monitoring? Because here by the pack, I'm monitoring here, right? By the time the packet reaches here, the TTL is reduced to 1. That's why it says 1. If I monitor here, the TTL will be 2, 3, because from here it starts, right? Pinging from here. So if you do it from here, do it from here. Still 1. Hmm. 2. The first package did not go through, that's why. Should be 2. Then it reduces to 1. 2 and then it goes and it receives an unreachable. Yeah, so the rest of the packets will be 2. The first will be 1, then it will be 2, right? The first one will go here. When it gets a unreachable back, then 2. So 2 will be the last one which he's gonna send, because 2 hops is the last hops he will have. Okay, this is good, but can I ping from R1? Can I trace out from R1? I can go to 192.1.20.10 and that's it. Why? Because the ICMP from R1 is not allowed. It's a separate packet that is coming in. ICMP from R1 is not allowed to come back in. So how do I allow this in? Same access list, permit ICMP from any to any, but which one? I have many. There's also one called traceroute, the one which is used in traceroute. So allow the traceroute ICMP to come back in. Check now.
And applied the
Yeah,
applied
I have applied it. I have applied it. INF, right? Is it sending it back? Sending unreachable back, right? Let's allow unreachable also. Access list, INF, permit, ICMP, any, unreachable. Okay. Okay, because the unreachable is coming back in and it is allowed. Okay, is this clear? Clear? The only thing I wanted you to see here is the decrement TTL, and you know how to use it now. You know how to use those advanced options. Which ones? Policy map, global underscore policy, and class, what was it called? Class trace. And then you have some options. We checked these options already. We know these. We know inspect, priority, police. These are QoS ones and these are inspect ones. The only thing that was left was set. So set, only one option, which is connection. And then you have certain values. Which ones? Decrement TTL we did. Random sequence number I showed you. And advanced options also we did. What these other ones are? These are just total number of connections that are allowed. These are the number of connections allowed. What do I mean by that? How many connections are allowed through the firewall? How many embryonic means connections in which the SYN has gone out? He's still waiting for SYNAC. It's called embryonic connections. Per client, how many connections per client should be allowed? Right? And timeout parameters. If a connection is waiting for some time, how long do you have to wait for it? The default values for these, if you want to check, is right there in your show run. Okay, these are the default values. Half closed connections, SIP, and this you don't need to know. This is your X-late, 3 hours for your X-late. Right? Connections, 1 hour for a default connection, a normal connection parameter. Half closed is 10 seconds. UDP is only allowed for how long? 2 minutes. ICMP?
2 seconds.
2 seconds. So when you allow UDP connection table, in the connection table, UDP connection is only allowed for 2 minutes. But TCP is allowed for how long?
1 hour.
Half closed means it's closed from one end, it's not closed from the other end. 10 minutes. Okay, and ICMP, because it's a useless protocol, it's only 2 seconds. So that's why when you inspect ping, you won't be able to see it in the connection table. By the time you do show connection, your speed is so slow that in 2 seconds it goes away. You'll never be able to see the connection. If you're fast enough, you will be, when you allow inspection of things in the connection table. Okay? Clear? 2 things we did today. What are those 2 things? We did TCP maps. Used for what? Anything which has anything to close to do with TCP. TCP options, TCP checksum, TCP headers is right here. And we also did connection parameters, in which you can do decrement TTL, random sequence number, and link this to the TCP map. So everything that is applied here. This is just a supplement of set connection. Which feature in set connection? Advanced options. Here you have 2, either TCP map. What is the other one? The other ones you know, set connection. Other one is decrement TTL. Random sequence number. Then the other ones. Which ones? The default limit and all the other different kinds of stuff, which is these ones. These ones just values. How many connections per client and all the other kind of stuff. Also all in here. Okay? Clear? That finishes your model policy framework. Okay? Now again, this is just the tip of the iceberg again. But what is important for you is to know the framework of how it works, not exactly each protocol, but the framework. So you should be flexible enough to apply it to any protocol that is given to you. I showed you HTTP, SMTP, FTP, right, and IPsec. Tomorrow, if you're thrown away with any other protocol, you should be able to use it based on the framework. That's why we call it a framework. They have included everything inside this framework. You can match on anything that you want. I showed you how to match on torrents yesterday. That's your homework for the weekend, by the way, to block torrents through that PIX that you connect. Okay? Do you get this? Clear? That will be all for today.